Welcome class, today's day 1 of distance learning. So this is going to be a new challenge for you and me. So my idea is that I'm going to present these videos every day. If you have questions, you can call or text the Google Voice phone number, or you can email me. I'll be available every day from 8 to 4. Sometimes I can respond after 4 p.m. It just depends on my schedule here. So without further ado, let's get started. Today we're going to start with chapter 11.1, Simplifying Radicals. So we're going to begin with this chapter by starting with the multiplication property of square roots. And this property says if you take the square root of a times b, two numbers being multiplied, then you can break this up into the square root of a times the square root of b. So we can use this property to simplify radicals. Okay, this is going to be an important lesson because a lot of you, when you use my yellow calculators, you say, Miss Ayers, these calculators are broken. I'm typing in the square root of 44 and it's giving me 2 square roots of 11. Why? And the reason is because the calculator is simplifying the radical square root of 44 into 2 square roots of 11. So I'm going to show you how that process works. Let's start with our first example. Simplify the square root of 192. Okay. So our goal is to simplify this number so that the radical has no factors that are perfect squares. So what we want to do is we want to look at the factors of 192 and determine, are any of those perfect squares? Can you think of any number that can factor into 192 that's a perfect square? I got it. 64 and 3. So if I multiply 64 times 3, then I'll get 192. Using the multiplication property of square roots, then, I can break up the square root of 192 into the square root of 64 times the square root of 3. Okay. The reason that this is nice is because, well, we know what the square root of 64 is. It's a nice, clean, whole number, 8. So I can simplify the square root of 64 to be 8, but I still need to multiply it by the square root of 3. And so the simplified form of the square root of 192 is going to be 8 square roots of 3. And that is how you can simplify a square root. Okay? Notice that the radical still exists. We're still taking the square root of a number, but it's a smaller number than 192. It's going to be 8 square roots of 3. Let's try another example. Let's simplify the square root of 45a to the 5th power. So this works not only with numbers, but with variables as well. As we try to identify some square roots here. So with the number 45, what would be a perfect square times another number that equals 45? If you guess 9 and 5, you'd be correct. 9 times 5 is 45, and 9 is a perfect square. The square root of 9 is 3. However, a can also be broken down into a perfect square. Let's recall our exponent laws. If you multiply two bases that are the same, but with different exponents, in order to multiply those, all you have to do is add those exponents. So is there a number of perfect square plus another number that would give me a to the 5th power? And the answer is yes. If you have a to the 4th, times a to the 1st. That's going to leave me with a to the 4th times a to the 1st, brings me back here to a to the 5th. So I'm looking for two numbers that multiply where one of the numbers is a perfect square. Using the multiplication property of square roots, then, I can break this up into one square root where I want to insert my perfect squares. So 9 times a to the 4th times my second factor that is a square root with the values that are not perfect squares. So 5 and a to the 1st power. Now I can simplify what's out front. The square root of 9a to the 4th, well, the square root of 9 we said was 3, and the square root of a to the 4th is a squared. Now I can multiply that with what I have left over. Whatever I have left over that is not a perfect square must stay under the radical sign, the square root of 5a. And so the square root of 45a to the 5th power simplified is going to be 3a squared times the square root of 5a. We can simplify using the multiplication property of square roots going the other way as well. So for example, if I have the square root of 8 times the square root of 12, I can simplify this by multiplying both the radicands under the same radical. So for example, this will look like the square root of now 8 times 12. Now remember, our final answer, in order to be in most simplest form, cannot have any factors inside the radical that are perfect squares. So you have two options. We can multiply these out and find the factors that are going to be perfect squares, or it could be easier to factor these right away, make it a larger radical. What are factors of 8 and 12 that you know are going to be the same? So you may identify that 4. So I have 4 times 2 times 4 times 3 now. What matches here? 4 times 4. And remember that the square root is the opposite of squaring a number. So now I have 4 squared underneath the square root symbol. So I can take out that 4. So this now becomes 4 square roots. Well, what do I have left? 2 times 3. And 2 times 3 is 6. So we have now simplified the square root of 8 times the square root of 12, written in radical form, in the simplest form, is going to be 4 square roots of 6. And that is our answer. Okay, last example using the multiplication property of square roots. Let's take now, if I have 3 square roots of 2b, 3 square roots of 2b, and multiply that now by 4 square roots of 10b. Okay, so where we want to start here is you want to start by multiplying the outside factors. So I know here that I can multiply both the radicals using the property that we've just learned. But what happens to these guys out here? Well, I still have 3 times 4. So you can begin there. 3 times 4 is 12. And now I'm going to multiply the other pieces other than the radical. Now remember, we're trying to find factors that are the same so that they can now come outside of that radical. So I have 2b, can't do much with 2b, times, but what about 10b? 10 is divisible by 2, so I could break out that 2b here and multiply that now by 5. So notice that 2b times 5 on the right-hand side here is going to equal my 10b. So this is still legal and fair to do. And the reason we want to do this is notice now that I have 2b's, which means that I can take the square root of those, because the square root of 2b squared is just going to be 2b. So now I have 12 on the outside multiplied by my 2b here, and whatever's in the radical must stay. So the only thing left, I've used these 2b's now, the only thing left here now is 5. So now I have 12 times 2b, which is going to give me 24b times the square root of 5. And that is going to be the product in simplest form. Next up, we're going to discuss the division property of square roots. The division property of square roots is similar to the multiplication property of square roots. We are going to be taking the two factors that are inside of the radical and separating them in a way that's going to be easier for us to simplify that radical. So here I have the square root of a divided by b. You can recall from your exponent rules that when we squared a number that was a fraction, we squared the top and squared the bottom. We're going to be using that same idea here, and we are going to be taking the square root of the top, the square root of a, and dividing it by the square root of b. So we have broken up this fraction into the numerator, taking the square root of the numerator, and taking the square root of the denominator separately. For this, we are going to have to recall from our exponent laws that if I have x to the a power divided by x to the b power, when you divide powers with the same base, you're going to subtract the exponents. Subtract the exponents. So we're going to need to remember that from our exponent law chapter. Let's start with an example. If I have the square root of 11 over 49, okay? So we're going to break this up into the numerator and the denominator. I have the square root of 11 divided by now the square root of 49. And the reason that this is nice and beautiful is that, well, I know that square root of 49 is. The square root of 49 is 7. So now I have the square root of 11 divided by 7. And that is going to be this radical in simplest form. Again, this property is going to apply to variables as well as numbers. So if I have the square root of 25 divided by b to the fourth, I can break this up by taking the square root of the numerator 25 and taking the square root of the denominator b to the fourth. The square root of 25 is 5 divided by the square root of b to the fourth. So what number added to itself, remember the exponent law is when you're multiplying with the same base, you're going to add the exponents. So what two numbers that are the same are going to add up to 4? Well, 2 plus 2 is 4. So the square root of b to the fourth is b squared. And so now our simplified answer is going to be 5 over b squared. Sometimes the numerator and the denominator will not be perfect squares. In these situations, it may be easier to divide the numbers in the fraction before we start taking the square roots. So let's look at an example. Okay. If I have the square root of 88 divided by 11, okay? 88 is not a perfect square and neither is 11. However, I do know that 88 divided by 11 is going to give you the square root now. 88 divided by 11 is 8. And 8, from our earlier examples, we can factor. We can factor this into a perfect square times another number. So that perfect square that we're going to be left with, or we're going to have here, is going to be 4 times the square root of 2. 4 times the square root of 2. And this is nice because, again, 4 is a perfect square. And so now this answer becomes this 2 square roots of 2. Okay. I tried that green, but I don't think that we can see it as well. I was trying to be festive for St. Patrick's Day. I have a darker green. Let's try that. Let's do another example here. The square root of 12a to the third power divided by 27a. So again, 12, 27, not perfect squares. Neither is a to the third power a. So let's divide first. Remember, you can divide or simplify your numbers here. 12 isn't divisible by 27, but we do know that they're both divisible by 3. What is 12 divided by 3 is 4. So I have 4 here. I can simplify the fraction 12 27ths to be 4 ninths. 12 divided by 3 is 4. 27 divided by 3 is 9. And then we know from our exponent laws that a to the third divided by a, you need to subtract the exponents. Remember, this has an exponent of 1. It's just invisible. 3 minus 1 is 2. And that exponent is positive, so it needs to live in the numerator. So this is 4a squared divided by 9, which is a beautiful thing to end up with because we know that 4 is a perfect square, a squared is a perfect square, and so is 9. So now I could take the square root of the whole thing. The square root of 4 is going to be 2a divided by the square root of 9, which is 3. So our answer here in simplest form is 2a over 3. Yes.